Thank you.
Thank you.
Let's call this A here and call this B. Okay. We did this before. In the past, we did the type of question, for example, cosine of sine inverse of 3/5. I wonder if you remember that. It was in your test. Okay, and then we say let's say theta equals to sine inverse of 3/5, and then sine theta equals to 3/5, and then you did the triangle. Is it right?
Yes.
Okay, and so on and so forth. Now we do pretty much the same thing here. So let A be sine inverse of 3/5 and B be tangent inverse of 2. So sine A will be 3/5. And then if I draw the triangle, let's say this is A here, this is 3, this is 5, so this must be 4. And tangent B equals to 2, which, if I draw the triangle, if this is B, this is right angle, is 2 over 1, so this will be square root of 5. Now then, so using that let, then we will get equals to cosine A plus B, which according to formula 1,1, this is cosine A cosine B minus sine A sine B. And then we plug it in. What is cosine A? 4 over 5. Cosine B, 1 over radical 5 minus sine A, 3/5. Sine B, 2 over radical 5. That is equal to 4 minus 6 over 5 radical 5. That's 2 over negative 2 over 5 radical 5. That's negative of 2 radical 5 over 5. Okay, that's one. Let me ask you to do a similar problem because I like to ask this question. And not only me, I know Dr. Alwash, whenever he teaches this class, he always asks this kind of question. Mr. Chang also. So let's try, for example, I make the question. Sine of tangent inverse 3 minus secant inverse 2. Okay, let me give you 5 minutes to have a good feeling on this. Okay, let's see. We will call this A, we will call this B. So let A be tangent inverse of 3. So tangent A equals to 3. If I draw the right triangle, for example, This is A, this is 3, this is 1. What will this be?
Square root 10.
That's right. And for B, the secant inverse of 2, secant B will be 2. So this is 2 over 1 here. This will
Square
be
root 3.
okay. Now then, using that substitution, then we get this guy, with this substitution, we get sine of A minus B. Is it right?
Yes.
Which will be sine A cosine B minus cosine A sine B. Okay, now then that will be sine A is 3 over radical 10. Cosine B is
It's 1/2.
half. Cosine A will be 1 over radical 10. And sine B will be
1/2.
3. I think it's sine B. Radical
Sine B,
3
my-
over 2. So that will be 3 minus radical 3 over 2 radical 10. Rationalize the denominator, I get 3 radical 10 minus square root of 30 over 1. Okay, now actually another good question will be where is that angle tangent inverse 3 minus secant inverse 2 located? Is it quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4? Here's the thing. Now, we know the A because tangent inverse 3 has to be in quadrant 1, right? So A must be in quadrant 1. Likewise, B also in quadrant 1. Okay, basically, A is between 0 degrees to 90 degrees. B will be from 0 degrees to 90 degrees. Okay, so when I subtract A minus B, then the highest value will be 90 subtracted by 0. The smallest value will be 0 minus 90. Okay. So basically it's either in quadrant 1, either it is in quadrant 1 or quadrant -1. Okay. You see, from negative 90 degree to 0, that's quadrant -1. From 0 to 90 degree, it's quadrant 1. Now, however, sine of A minus B is positive or negative? Is this value positive or negative?
Negative because there's one negative in there?
Huh?
Is it negative because there's one negative in the middle?
One negative in the middle. What
You thought minus.
Oh,
You know how
no. Yeah, but well, you need to compute the square root of 3 square root of 10 minus square root of 30. Is it positive or negative?
That's positive.
Yeah, that's I believe that should be positive. At least I see it this way. 3 square root of 10 is square root of 9 times square root of 10. That's square root of 90, right? So 3 square root of 10 minus square root of 30 is the same to square root of 90 minus square root of 30. We can be sure that's positive, right? Okay, divided by 20, that's still positive. Therefore, sign of the difference is positive. Now, in quadrant, sign is positive in quadrant 1 or quadrant -1?
Quadrant
Quadrant
1.
1.
That's in quadrant 1. Okay, that's if we add them though. Now, suppose that's if we subtract. When you subtract inequalities, the larger will be the largest here minus the smallest here. Okay, now let me write it down. A is between 0 to 90. B, let's say in this case, happen to be the same, also 0 to 90. Okay, so the maximum of A minus B will happen when you maximize the A and minimize the B. Think about that. The maximum of the difference happens when you get the maximum of A, which is 90, minus the minimum of B, which is 0. Right? That's 90 minus 0. Now, how about the minimum? The minimum of A minus B is when you minimize the A, and maximize the B. Okay? Now, how about if we do the addition? What is the maximum value of A plus B?
90 plus 0.
No. The sum will be maximum if both of them maximum. It will be 90 plus 90. Okay? And the minimum will be the minimum for each. 0 plus
Be 0.
Okay? Now let's do another, instead of just doing it that way, let's do another idea. Suppose, so this is more or less related to our issue earlier, but the situation is different. Suppose we have x is between, let's say, 24 to 50, and the y is between 12 to 30. Now, my question is, what is the maximum value of x plus y?
Plus 50.
Hmm?
50 plus 12.
No. 50 plus 30. The maximum of sum equals to the sum of maximum. So if you want to maximize the sum, okay, maximize my income and my wife's income, then each one of us has to maximize. Okay, now to minimize, then minimize the sum, so you get the minimum of one of them plus the minimum of the other one. Okay, so however you add x plus y, okay, the smallest possible sum will be 36. It won't be less than 36. And it won't be more than 80. Okay, now how about the maximum for the difference, x minus y? Now to maximize this difference, you maximize the x, which is 50, and you minimize what you subtract. While the minimum will be, you minimize the x and maximize the y. So x minus y must be between 38 and -6. X plus y must be between 36 and 80. Okay, well, anyway, that's how I get that here. Because I subtract, then the maximum minus the minimum Okay, that's to get the maximum. The minimum will be the minimum minus the maximum. Erase this. Another small examples, which I don't think I will finish. Example 3. What happens if I want this tangent of cosecant inverse of x? I mean 2 times cosecant inverse of x. Then the way we'll do it, let me call this theta. Okay, let theta be cosecant inverse of x. Cosecant theta equals to x. Let me say x is positive. Now then, when I draw the triangle, this is theta, this is x, this is 1. So this will be square root of x squared minus 1. Now, using that substitution, we get tangent of 2 theta, which is 2 tangent theta over 1 minus tangent square theta. That's 2 times 1 over square root of x squared minus 1 big over 1 minus 1 over x squared minus 1. Multiply by the LCD x squared minus 1. I will get on the top, I get 2 times square root of x squared minus 1. At the bottom, I get x squared minus 1 minus 1. Okay. That's for this first one. Basically applying the formulas we'll have from 5.2, 5.3, and actually maybe 5.4 later on, okay, together with the inverse function. Now, how about group 4? That's product to sum formula. For group 4 and group 5, you don't need to memorize. Don't need to memorize. On your test, I will provide the notes or the formulas, okay? For group 4 and group 5, I will provide the formulas. What we will do here, I will write the formulas down and then prove them and then use them, okay? So group 4, 1, cosine A cosine B equals to cosine A cosine B equals to 1/2 of cosine sum plus cosine difference. Second, sine A sine B is equal to negative 1/2. There's a negative there. Of cosine sum minus cosine difference. Sine A cosine B, that's equals to 1/2 sine sum plus sine difference. And then last one, cosine A sine B equals to 1/2. Do you hear my son?
Yeah.
Minus sine of difference. Okay, do you need to memorize this? Not until you are in Calc 2. Even in Calc 2, you don't really see a lot of problems regarding this. In pre-calculus, you may see some questions from here though. Okay, how about the proof? At least let me ask you to copy that down first. Copy this down. Let me know if you are done. Are you done? I just want you to copy that down.
Got it.
Okay, everybody else? Now, the proof is actually quite simple, a lot shorter than what we had before. However, it does take some memorization from formula group number 1. Okay, we will actually do the proof from right to left. Okay, so for example, the first one, to prove for the first one, I want you to do this. Write the formula for cosine A plus B first. Okay, you do it. I give you 1 minute, 40 seconds. That will be cosine A cosine B minus sine A sine B. I hope you memorized this already. Now, the next thing right below it, I want you to write the expansion for cosine A minus B. That will be cosine A cosine B plus sine A sine B. notice that if I add them, then on the left-hand side, I will get cosine A plus B plus cosine A minus B. While on the right-hand side, you see the first terms are the same terms. Right? They are the same terms. So that will be 2 times cosine A cosine B. Okay? While the last two terms, the last terms for the first one and the last term for the second one, they are opposite to each other. You see that? So when you add them, what happened?
They cancel?
They cancel each other. That's right. So then, if I continue on the last step here, if I divide both sides by 2, I will get 1/2 of that cosine sum plus cosine difference. Okay? Now that's the proof for the first one. Now, in fact, I would like you to continue from what we have here. Instead of adding, try subtracting. If you subtract, what happened? I will use different color. Okay, if I subtract, I will get cosine A plus B minus cosine A minus B on the left-hand side. Okay. Now, when I subtract, what happened to the blue box?
It gets canceled out.
They cancel out. That's right. The blue box will cancel. What happened with the red box?
Do they cancel out too or no?
No, we are not adding. We are subtracting. So you will get negative blah minus blah. Right? That will be negative 2 of sine A sine B. Okay, and finally, I divide by negative 1/2. I get what I need for formula number 2. Okay, that's for the second formula. Now, I wonder why my daughter's crying. Let me ask you to try to prove formula number 3 and number 4. The technique is actually very similar. What you will do, you will write the expansion for sine of sum and the expansion for sine of difference. Kind of like do the pancake. You pancake them like this and see what happens when you add, see what happens when you subtract. Okay? Let me ask you to do the proof. Let's say together with your break, we come back at right now 7, let's say 5 minutes plus. Let's say we come back at 8:20. I hope you do the same thing for now. And then when I add this, I get sine of sum plus sine of difference. And what happened to the right hand side? Notice that the first terms, the same terms, right? So I get 2 times sine A cosine B. And the last terms, they are opposite to each other such that when I add, they cancel. Okay? Now then, I divide by 2 both sides, then I get 1/2 times sine sum plus sine difference equals to sine A cosine B. Okay, that's the proof for formula 3. And to prove for formula 4, we will subtract. When we subtract, we will get sine sum minus sine difference. Sine sum minus sine difference. And you will see that the first term, the red box, will cancel because we are subtracting the like terms, right? Okay, and the blue box, you subtract the opposite, that's basically becomes adding the same term. So I will get 2 times cosine A sine B. Then divide by 2 both sides, give me what I need. Okay, that's for formula number 4. So I basically prove a pair using the cosine sum and cosine difference, and another pair by sine sum and sine difference. Now, how to use this? Again, the assumption is you use your notes, so I don't need you to memorize this formula, but you still need to know how to use this formula. Okay, if I take a look from our textbook, let's say we do number, let's say number 16. Number 16 on that 5.5, simplify 10 sine 5x sine 3x. Simplify that from product to difference. Now, this will be my product of sines. Okay, that will be 10 times 1/2 sine of sum. I'm sorry, that's sine, my bad. It's not. That's negative 1/2. That's negative 1/2 cosine of sum minus cosine of difference. Okay, that will give me negative 5 times cosine of 8x minus cosine of 2x. Okay, that's it. That's all you need to do. Okay, now of course, which one to use in what situation, then you need to use, you need to practice. Okay, now that's group number 4. Group number 5. Group 5, that's sum to product. Formulas. Again, you don't need to memorize this formula, but you need to know how to use it. The first one is cosine x plus cosine y equals to 2 cosine half of the sum cosine half of the difference. Difference of cosine equals to -2 times sine of half of the sum times sine half of the difference. The third one,
Present. For sine A times sine B, it equals to -1/2. You were saying?
Yeah.
I'm looking at the book right now, and it says it's +1/2, but the signs are mixed. What is there a reason why the book does it different?
Oh, the book actually write it this way. The book actually don't have the negative. The book doesn't have the negative, but they switch the order of the subtraction. So our textbook version is this: sine A sine B equals to 1/2 of cosine difference minus cosine sum. You see, so they actually reverse the order of the subtraction. The subtraction here and the subtraction here, they reverse it. I mean, cosine sum minus cosine difference, when they reverse it, they get rid of the negative sign.
Okay.
Okay, but I prefer this pattern. I prefer the pattern that I have here. The reason is I maintain A plus B in the first term and A minus B in the second term. You see what I mean?
Yeah.
Okay.
Yeah.
Mm-hmm. Now let's go back here. Good that you mentioned it. Otherwise, I forget to mention that too. The third formula, sine x plus sine y equals to 2 times sine of half of the sum cosine half of the difference. While sine x minus sine y will be 2 times cosine of half of the sum sine half of the difference. Now I will prove only one of them. Okay, I will prove only one of them. But actually, the proof that I use for any one of these will be applicable exactly the same way with the rest. Now, I will pick the first one, for example, from group 4-1. From group 4-1, we have that cosine A cosine B equals to 1/2 cosine sum plus cosine difference. I take from group 4-1. I basically copy that down. Notice what happened if I multiply by 2. If I multiply by 2, I get 2 cosine A cosine B equals to cosine sum plus cosine difference. Can you follow me? Okay, this is what I will do next. I want you to notice some pattern. Notice that I have cosine x plus cosine y, right? Okay, my x was originally a plus b. My y is a minus b. Okay, so let x equals to a plus b, and the y is a minus b. Okay, so basically later on, this equation later on the right hand side will be cosine x plus cosine y. Is it right? Okay, that's what happened on the right hand side. Now the thing is, the one in question is, what will a and b be? Now I will need to solve that from here, and notice that if I add this, I get x plus y equals to what?
Two A.
2a. Therefore, I can substitute a by x plus y over 2, right? On the other hand, if I subtract, what will happen? X minus y equals to 2b. Is that right? Therefore, b is x minus y over 2. Notice that I will substitute that right away. 2 times cosine A cosine B equals to that. That's the end of the proof. Okay? The thing is, you can apply this technique of substitution, this method, to group 5-2, group 5-3, and formula 5-2, 5-3, and 5-4. Okay? 5-2, 5-3, 5-4. Okay? Okay then, Thomas, how do we use this? How do we use this formula? Then we do examples, exercise. For example, number 28. Compute and simplify as much as possible. Number 28, we have sine 75 degrees minus sine 15 degrees. Sine minus sine. Sine minus sine is equal to 2 times cosine of half of the sum times sine of half of the difference. Now check your formula. Okay, so this will be, let me go on. This is 2 cosine what? 45 degrees. Sine 30 degrees. Right? That's 2 times square root of 2 over 2 times 1/2. That will be square root of 2 over 2. How about applying this to prove it? Let's say proof number 32. Prove that cotangent x is equal to the sum of cosine 3x plus cosine x divided by the difference of sine 3x minus sine x. Now to prove it, we have formula on for the right hand side. So I will prove from the right to left. Now let me give you 3 minutes to use formula 5.1 on the top and 5.4 at the bottom. Okay, you try it. This will be 2 cosine sum over 2 times cosine difference over 2. Big over. Sine minus sine will be 2 cosine sum over 2 sine difference over 2. So you see that this cancels, right? And this also cancels. Well, you can simplify them first if you want. Let me simplify them first. So they are better looking. So I get 2 cosine 2x cosine x big over 2 cosine 2x sine x. When I do cancellation, I get cosine x over sine x. That's cotangent x. That's what we have on the left-hand side. Therefore, that's the end of the proof. Okay, from this 5.5, suggested homework will be number 1 to number 35. Number 1 to number. Okay, now that's for 5.5. I'm about to move on to chapter 6. Six point one. Solving trig equation. Now notice that sine x has the period is, what's the period? 360 degrees, or if we want to say it in radian is 2 pi, right? Okay. Cosine x also have the same period. Tangent x, however, has the period of 180 degrees. Or simply pi. Now, that's one of the key ingredients we need to solve our trig equation. Let's say, for example, suppose I want to solve sine x equals to 1/2. And we want this x to be in degrees. Now, then x will be what degrees? Ask yourself, sine what give you 1/2? Without using calculator. In degrees. Now, that's 30 degrees, right?
Yes.
Okay, 30 degrees. Now, however, sine is positive not only in quadrant 1, also in quadrant 2. Okay, so what is the angle in quadrant 2 such that sine of that angle is 1/2? Notice that whatever that angle be, it must have the same reference angle to the reference angle we have there. Okay, so what is the angle in quadrant 2 whose reference angle also 30 degrees?
Cosine 60 degrees?
No. What is the angle? Okay, so you will see sine 30 degrees is 1/2, sine 150 degrees also 1/2. You see what I mean? There are two solutions. One of them in quadrant 1, 30 degrees, and the other one is in quadrant 2, the same reference angle. Okay, now if the question says find x between 0 to 360 degrees, then we are done here. But if we want the answers in general, Then we need to add the period, 360 degrees n, add the period, 360 degrees n, for n equals to an integer. Okay, now this is where this issue comes in. Okay, so a lot of memorization here. Let's do more examples. I do question number 4 in section 6.1. This is page 286. Number 4. 2 cosine, so let me write the question first. Solve for theta between 0 degrees to 360 degrees without using calculator. I have 2 cosine theta plus square root of 3 equals to 0. So I isolate the cosine theta first. Cosine theta equals to negative radical 3 over 2. Okay, now before I go on, I ask myself, what is the reference angle? Cosine theta hat equals to radical 3 over 2. I just use the positive part. That way I get my reference angle. And the reference angle is 30 degrees, right? Now then, from there you go back. Cosine is negative in quadrant what?
2 and 3.
3.
2 and 3. So in quadrant 2, what's the angle such that the reference angle is 30 degrees? So what is the angle here?
$150.
Huh? 150 degrees, okay. And how about the angle in quadrant 3?
210.
210 degrees. Okay, now suppose I change the question a bit. We are done actually, we are done here. But if I modify the question a bit and I say solve for all degree solutions. Of 2 cosine theta plus radical 3 equals to 0. So it's actually the same question, okay? But this time our solution is not limited to only the first period from 0 to 360 degrees. We want the general solution, okay? We want the general solution. So we get cosine theta equals to negative radical 3 over 2. Okay, now from there we see, oh, you know what? The theta hat is 30 degrees, right? Now then, but I need that to be negative. Then it must be quadrant 2 plus 360 degree n. Any 360 degrees multiple of that number, okay, and 210 plus 360 degree n. So I hope you see the difference between if we solve only in the first period from 0 to 360 degrees, you don't need to add the 360-degree end. If you need all the solutions, then you need to make sure that you add that 360-degree end.
So if it said solve for data between 0 degrees and 180 degrees, it would just be data equals to 150 degrees?
Oh, suppose, good question. Suppose we change the question, solve for theta from 0 degrees to what degrees?
180?
180? Oh yeah, if it is 180, then it will be only 150 degrees. Now I have this in mind. What happens if I ask from 0 to 720 degrees? Then we will get the general solution first. Okay, we get the general solution first, and then we use when n equals to 0, when n equals to 0, we get that, right? When n equals to 1, we get theta equals to 510 degrees and 570 degrees. When n equals to 2, I get theta equals to 720, 870 degrees. But it's more than 720, so you cross it out. You see what I mean? This guy here will provide us the general solution. This guy here will provide us the general solution. In fact, if you think about it, you can get the general solution first, and then if you need only from 0 to 360, you will see when n equals to 0, you get that 150 to 10. When n equals to 1, it's already outside. Okay, so I somehow recommend my students to get the general solution first. Okay. Now, how about if we want the solution in radian? Let's say, for example, question number 10. For t between 0 to 2 pi, solve 5 cosine t plus square root of 12 equals to cosine t. I subtract by cosine t, both sides I get 4 cosine t, and I move the square root of 12 to the other side, I get negative square root of 12. You know what, I don't like that. I will divide by 4. However, let me simplify square root of 12 first. Square root of 12, what will that be if I simplify?
Negative 2 radical 3.
Negative 2 radical 3, that's right. And that simplifies to be cosine t equals to negative radical 3 over 2. Okay, now then let's get the reference angle first. The t hat will be cosine t hat is radical 3 over 2. So what is t hat?
5?
Ah, no. Pi over 6, 30 degrees, right?
Yeah.
Cosine 30 degrees is radical 3 over 2, but I need to write it in radian right now. Now, we go back. Cosine is negative in quadrant 2 and quadrant 3. Cosine t is negative when t is in quadrant 2 and quadrant 3. Okay, so what will the t be? what is the angle in quadrant 2 and quadrant 3 such that the reference angle is pi over 6.
Pi minus pi over 6 equals pi over 6.
Okay, I like that one. How about in quadrant 3?
Pi plus pi over 6 equals 7 pi over 6.
Okay. And that's it, we are done. Because the question is in this interval only. Okay, but if we need general solution, then we will get t equals to 5 pi over 6
Plus
plus
2 pi.
2 pi n. Okay, 7 pi over 6 plus 2 pi n for n an integer. Okay, let's do more. Let's do more. We get the foundation already. Let's do more. Suppose I do number 24. Number 24, we want the x is between 0 to 2 pi. Solve number 24, cosine x minus 2 sine x cosine x equals 0. We will factor first. Factor the common factor cosine x. I get 1 minus 2 sine x equals 0.
Set them to 0.
Okay, so either cosine x equals to 0 or 1 minus 2 sine x equals to 0.
Sine x equals 1 over half.
The sine x equals to 1/2, okay. Okay, so if sine x equals to 1/2, what will x be? In quadrant 1?
Pi over 2.
No,
Oh,
pi over 6, 30 degrees, right? And then in quadrant 2, 5 pi over 6, the same reference angle. Now, how about cosine x equals to 0? What will x be? Cosine what is 0?
pi over 2.
Pi over 2. And what else?
3 pi over 2.
3 pi over 2. Okay, that's all the solutions in this interval. Again, if we need all gradient solution, then the solutions will be x equals to pi over 6 plus 2 pi n, x equals to 5 pi over 6 plus 2 pi n, x equals to pi over 2 plus 2 pi n, x equals to 3 pi over 2 plus 2 n. But let me go on a little bit further. These guys here are the same to the following, but there's something called condensation of solution. Don't worry about this. I just want you to be aware that your solution may look different from your textbook because our textbook do condensation. Okay, what do you mean by condensation, Thomas? Think about that pi over 2. Pi over 2 is located here, right? Pi over 2 is located here, plus 2 pi, same place, plus 2 pi, same place, plus 2 pi, same place. Now, the last solution here is 3 pi over 2 plus 2 pi, same place, plus 2 pi, same place. Okay? But I can condense it this way. I can say, I can combine these two here. I can combine these two here becomes x equals to pi over 2 plus pi m. Why? Pi over 2 plus pi is here. Let me use this color. Plus pi give me this. Plus pi give me this. Plus pi give me this. Plus pi give me that. Okay, so I can get these two solutions being condensed together becomes this. Okay, now I expect that when you do the homework at home, you will get this part here, but the solution you see in your book may be something like that. It has something to do with the period though. Okay, and this don't really happen. It sometimes happen, but not happen all the time. Okay, only sometimes, not all the time. Let's say we do next one. How about number 22? We have not done number 22. The tangent. Number 22, we have tangent x. Still, the x is between 0 to 2 pi. Tangent x times tangent x plus 1. Oh, they factor it for us already, huh? So either tangent x equals to 0 or tangent x equals to -1. Tangent x equals to 0 when x equals to 0 or x equals to pi. Okay, actually not necessary. You know that the period for tangent or cotangent is pi. So if 0 is the answer, then pi also the answer. Okay, while x equals to -1 will be when x is 5 pi over, I'm sorry, not 5 pi over 3 pi over 4. And if I add pi, it will be 7 pi over. If we need a general solution, then it will be x equals to 0 plus pi n, x equals to 3 pi over 4 plus pi n. Notice that this is equals to 0 plus pi times 1. And this is equals to 3 pi over 4 plus pi times 1. Next question. I will do 2 more questions and then I'll let you go. Number 36. Number 36. Find all solutions. Find all solutions in 0 to 360. For 36, sine squared theta minus sine theta minus 1 equals to 0. Now they say here you will need to use quadratic formula. Basically, it's not factorable, and round it to the 10th of the degree. Later on, apparently, we will need to use calculator. Okay. Now, the way we solve that, I will use substitution first. Let u equals to sine theta. So my equation now becomes u squared minus u minus 1 equals 0. And then, by quadratic formula, u equals to, what is the a, by the way? What is the a?
1.
How about the b?
-1.
1.
How about the c?
-1.
Okay, so when I plug that in, it will be negative b plus minus square root of b squared minus 4ac over 2a. Now, I think at this point here, something you have not seen if you didn't do intermediate algebra recently. Now, let's split this. Let's split this. So u1, the first solution is 1 plus square root of 5 over 2. And the other solution is 1 minus square root of 5 over 2. Okay, now what will this be in decimal?
1.6181.
1.618.
What?
5 decimal places. One more.
Sorry, give me a second. I can do it.
Oh, no, it's not.
It's actually 1.61805.
0.5. I get 0.3.
805.
I get 803. I get 803. Let's see. Yeah, I get 803. Okay, now then I will put it back. This is sine theta equals to 1.61803. But we know that the range of sine is from -1 to 1. Okay, so this one has no solution on this branch. If you ask what's the reason, because sine theta is the range for sine theta is from -1 to 1, not more than that. Okay. On the second branch, let's see. 1 minus square root of 5 divided by 2. I get negative 0.618 0.03. That's what our sine theta be. Now, then from here, the way we solve it, you do the reference angle first. Do the reference angle first. Okay, and then you sine inverse. Oh, I need that in radian. Oh, in degree, so I'm fine. So in degree, after I use my calculator, I get 38.17271 degrees. Now then I go back. I need the theta in quadrant 3 and in quadrant 4. In quadrant 3, that would be 180 degrees plus, let me say here, this is in quadrant 3 and this one in quadrant 4. Plus 38 degrees, I'm sorry, 38.17271 degrees, that's 218.17271 degrees. And in quadrant 4, that would be 360 degrees minus that reference angle. That's 321.82729 degrees. Okay, so the principle is actually the same, even though I get ugly numbers. Okay, I have calculator, I get ugly numbers. Okay, but because that's a negative, so I look at the reference angle first. I look at the reference angle first. And then I adjust that with the angles later on, with the quadrant later on. Okay. Now, what happens if we have, for example, question like number 48? Find all the solutions. Sine of 2a plus 50 degrees equals to square root of 3 over 2. Here's the idea. The way we'll solve it will be as the following. We will solve for blah first. Okay, as if we are doing the following. Sine blah equals to radical 3 over 2. Then blah will be what? What's the reference angle?
60 degrees.
60 degrees. And sine is positive in quadrant 1 and quadrant 2. You see what I mean? Okay. Now I change that ugly guy back to 2a plus 50 degrees equals to 60 degrees plus 360 degrees and or 2a plus 50 degrees equals to 120 degrees plus 360 degrees. Okay, so this is my blah, this is my blah. Now then from there you solve for a. Okay, so 2a equals to 10 plus 360 degrees, and divided by 2, there will be 5 degrees plus 180 degrees n. 2a equals to 70 degrees plus 360 degrees, and a is 35 degrees plus 180 degrees. Okay, so instead of solving for a right away, okay, we solve that package first, 2a plus 50 degrees, because we know what's the solution supposed to be. And then from there, we solve for a. Okay, now suggested homework from here. Suggested homework from here. 6.1. I would like you to do number 1 to number 53. Number 1 to number 53. Actually, let me ask you to do it this way instead. Or just do every other odd then. Just do every other odd so that you don't get overwhelmed. Okay, now on Wednesday, I will do 6.2, 6.3, and 6.4. Now, you may wonder, Thomas, what do you mean? So today you only cover 6.1 and 5.5. The thing is 6.2 and 6.3 are actually very similar to 6.1. Okay, so you will see that on Wednesday, we'll just do problems again for 6.2 and 6.3, and then I go on with 6.4. Okay, any question